All right, 5.4, fundamental theorem of calculus. It is part A, even though it doesn't say it on your paper. So, the fundamental theorem of calculus is actually not that difficult. There are two parts to it. The first part is simply stating if f is continuous on a closed interval a to b, then g of x is equal to the integral from a to x of f of t dt. And it is continuous on the closed interval ab and differentiable on the open interval from a to b. And g prime of x is equal to f of x. Okay, so what this is saying is that if I were to have a function f of t dt, or f of t, which is being either integrated or derived with respect to, or integrated with respect to t, I can't talk. If I were to integrate this function and then derive it again, I would end up right back where I was, which makes sense. If I ask you to derive this, you would get f prime of x equals 6x. Okay, well then on the other hand, if I were to give you this integral, 6 of x, and I were to ask you to integrate it, if you integrate it, hopefully you'd end up with, okay, so x is to the 1 power, but add 1, and then divide by my new exponent, so 6 divided by 2 is 3. So there's my integral, right? Okay, and then if I were to tell you, oh, you know what? Let me make a little change to the original problem. Once you integrate it, I want you to go ahead and derive it, right? Because that's what this equals. This means derive. So once I integrate it, I would derive it. All right, so please derive that for me. And then you should be all like, oh, 2 times 3 is 6, and then x, and oh, look at that. I ended up with what I already had with, or I ended up with what I already had, okay? These are the same. Because deriving something after you integrate it, it's as if you didn't do anything at all to that function. They cancel each other out. And that's what this part of the fundamental theorem of calculus is talking about. The only difference is, if this is what I started with, that's what I'm going to end up with. It's just that instead of in t, right? We're going to end up with x right there. So that's how we get f of x. Okay, so easy peasy. Example 1. So basically, what this is saying is, find g prime. G prime means the derivative of g. Here's g. This is g. All of this. So I'm going to derive that. So it's basically what I just said. If I were to derive that, okay, if I were to derive that integral, I would end up with the function I started with, but instead of t, I would have x. So I'm going to use capital letter W as the antiderivative. Okay, the antiderivative, I can't talk, I can't write, is big W of t. All right, so let's see. We normally integrate this, right? Okay, so the integral, and I'll write it out down here. Okay, so I end up with big W, but then I have to plug in an x, minus big W with a 2 plugged in, negative 2. And there is my integral. Now, they're asking me to find the derivative, right? The derivative of g. This is g. So the derivative means, okay, I'm going to go ahead and derive this integral, which means I need the derivative of this, and I need the derivative of that. Okay, well, let's see. The derivative of big W, x of x, right? Remember I said big W, capital W will be the antiderivative. So The derivative of that would be just little w again, minus, let's see, the derivative of w with a negative 2 plugged in. Now notice, this is a constant. So if I plug in negative 2 to whatever w is, whatever equation, I'm going to get a number. See here I have x. I'm not going to get a number. I'm always going to have x. So when I derive a number, I get 0. So my answer is w of x. Well, look at that. If I had, at the very beginning, just looked at this and plugged in the x, I would have my answer. Example 2, find f prime of x. So this is f of x, and I'm looking for the derivative. But I'll do this one last time the long way, but after this, no more. So let's see. If I integrate it, I get t cubed divided by 3 minus t squared divided by 2, so the 2's cancel out. Okay, and now I'm evaluating this from x to negative 2. Okay, so plug in the x. I get x cubed over 3 minus x squared. Plug in the negative 2. I get negative 8 over 3 minus 4. So basically this is my answer, right? I guess I could clean it up a little bit. X cubed over 3 minus x squared minus, all right, negative 8/3 and negative 4. I could, what's the word? Simplify that sum, but I don't have to because I'm going to derive this, and these are just constants, and when you derive a constant, you get 0. The only thing I'm going to do is, okay, this is a negative, and this is a negative, so they're going to become positive, and this is a negative also, so I've got positives all around. So positive 8/3 and positive 4. Okay, so this is, right here, the integral, right? I integrated f of x, but see, what they want the derivative of f of x. So, or I said that wrong, I'm sorry. I integrated this function, and the integral is f of x. They want the derivative of f of x. So this right here is f of x. So derive it. F prime of x equals 3x squared divided by 3. Oh, the 3's cancel out, so I don't really need them. Minus 2x plus 0. If you look at this right here, should look exactly like this, only that instead of t's, it's x squared minus 2x. Same exact thing. And that's the fundamental theorem of calculus, at least one part of it. Okay, so this right here should be very easy. You should be like, oh, there's a t, and that's it, no more t's. So this x is going to replace every single t. So my answer, because this is the integral, this is an integral, and I am deriving that integral, my answer is simply 5x squared minus 6x plus 1. That's it. Okay, next, the fundamental theorem of calculus with the chain rule. This works the same way, only that chain rule comes into effect when the limits are functions. Now, when the limit's x, that is also a function, but the derivative of x is 1, so it's like you're not doing anything else. But this is when the limits are both functions and they're a little more, or just one of them, a little more complicated than just x, like 3x squared or 4x or tangent x, something like that. Now notice, all they do is they plug in the u to the x, see? They plugged it in, but then multiplied it by du. Okay? They took vx and plugged it in right here, but then multiplied by dv. And then, of course, subtracted. All right, so here, we're going to take turns. Do this one first. So it's going to be f of 3x, but then times the derivative of that, which is 3, and then minus, and now we're going to do this one, f of x squared times the derivative of that, which is 2x. And I guess this could be rewritten, not that it's anything else but practice. Right, next. So here, same thing. Do this one first. So it's the square root of 4x cubed times the derivative of that, which is 12x squared, minus, and so now we're going to do this one, the square root of x squared times 2x. And this could be simplified. I'm not going to worry about it too much, the simplifying part anyway. But I'll go ahead and write 12x squared 4x cubed minus 2x, but I mean really x squared and x is just x, right? So if I have one x and another x, that's a total of 2x's, so 2x squared. That's an x times x. And like I said, this could be simplified further. It actually could go as far as this. I'll just write it out. Okay, next. Example 6. Suppose g of x equals the integral from 3x squared, or 5x to 3x squared of the square root of 1 plus 2t cubed dt. Find g prime. Alright, see? I'm looking for the derivative of this function. And this function is the integral here. So I'm deriving the integral, which basically they cancel out. My only real job here, really, is to plug these in wherever there's t. Okay, so 1 plus 3x squared cubed times the derivative of that, which is 6x, minus, and so now I'm plugging in the 5x. So now I'm doing this. The square root of 1 plus 5x cubed times the derivative of that, which is 5. And I'm perfectly good with this. We don't have to simplify, not today. Okay, on the back. The fundamental theorem of calculus part 2. Now, if this we've already done. Now we just have a name to go along with it. When you are integrating, right, when you're solving for integrals, you are doing the fundamental theorem of calculus. Okay, so if f is continuous at every point of the closed interval a to b, then the integral from a to b of f of x dx equals fb minus f of a, where f of x is an antiderivative of f of x. So the uppercase letter f is the antiderivative of the lowercase letter f. Well, you know what? Let me touch base on that. So that means if I take this function, which is the antiderivative, okay, if I were to derive it, I would end up with f prime, big F, right, prime of x, and that derivative would equal my little f. Okay, all right. So part A here, well actually part B. Let's do part B first. I should have done this in a different order. So here I am integrating the derivative. Okay, so if I antiderive f prime, I get f. Plug in the 9, plug in the 4, and there's my answer. All right, part A. So this is just integrating. So I get 1 becomes x cosine. See, what did I have to derive to get cosine? So that's sine. And then I'm evaluating this from pi over 2 to pi. So here's pi over 2. Here are my, what do you call these? My coordinates are 0, 1, and here my coordinates are negative 1, 0. So let's see. I'm going to plug in the pi and then the pi minus 2. So pi minus sine of pi, okay, or sorry, plus, sorry, minus pi over 2 plus sine of pi over 2. So let's see. I have pi plus sine of pi is right there, 0. And then I have pi over 2 plus, and sine of pi over 2 is 1. And there's my answer, basically. I have pi minus pi over 2 minus 1. So I have a whole minus half, so that's just half of a pi left, minus 1. And there's my answer, right there. Example 8. If the average value of the function f on the interval from a to b, closed interval, is 16, then the integral from a to b of f of x dx equals... So, that's what we're figuring out. What does that equal? Average value is from the last class's notes. Average value is when you do this. Okay? They're telling me that the average value, this formula, is 16. It equals 16. What they want me to do is figure out what this part equals. That's what they want me to do. Okay, so mathematically, a little bit of algebra, if I want to figure out what the boxed stuff is, the green stuff, I'm going to get rid of the 1 over b minus a. That's a fraction. Let's see, how do we get rid of fractions? We multiply by the reciprocal. Both sides, right? We multiply both sides by the reciprocal. This goes away. I am now left with this part equaling 16 times b minus a. Or, if I simplify this a little, I get 16b minus 16a. And here, folks, is my answer. The integral from a to b of f of x dx equals 16b minus 16a. Example 9. If the integral from 3 to 5 of f of x dx equals 11, then the integral from 3 to 5 of f of x plus 9 dx equals... Okay. This probably should have had some parentheses there. So, what they're telling me is... well, first of all, let me split this up. The integral from 3 to 5 of f of x dx, that's this right here, plus the integral from 3 to 5 of 9 dx, that's this right here. Okay, this is the same thing. It's equivalent. Well, they've told me that this part right here is 11. So this is 11. 11 plus integrate the 9. If I integrate 9, I get 9x. So 11 plus, let's see, I get 9x, right? Evaluated from 3 to 5. So 11 plus, right? Let's do this. Okay, so plug in the 5. So 9 times 5 is 45 minus 9 times 3, which is 27. So 11 plus, so 15 plus 3, that's 18. 29. right? You could have also thought of this as geometrically. Like this right here is a graph that looks like this. This is 9. Let's call this 3. Let's call that 5. And here's my graph. And they're basically asking for the area from here to here, which is a rectangle. Um, it is 9 long. And let's see, 5 minus 3 is 2, right? And 2 wide, which has an area of 18, which is the same as I got here, right? Okay, last one. F of 1 equals 12. F prime of x is continuous, and the integral from 1 to 4 of f prime of x is 17. What is the value of f of 4? Okay, so notice how I have, and they're talking about the derivative, they're talking about the original function, then they're talking about integrating the derivative, which should get you, what should it get you? If I integrate the derivative, it should get me the original function. So let's see. From 1 to 4, f prime of x is equal to, okay, so if I integrate the derivative, I will get the original function, right? So basically I'm looking for the antiderivative of this. So f, plug in the 4, minus f, plug in the 1. Okay. Right, because, you know what? Let me write the step I didn't write. F of x evaluated from 1 to 4. Alright, so now, look back at the information. This is what we're looking for. Here it is. I'm looking for this. They did provide me with this piece of information right here. F of 1 is 12. Ooh, look at that. F of 1 is 12. I still don't know what this is. And last piece of information, they did tell me that my integral is equal to 17. My integral is equal to 17. So this is equal to 17. Do a little math. Add 12. Add 12. F of 4 equals 29. Okay, the 29s were a coincidence. No big deal. Homework. Make sure all the other homeworks are completed. Anything that has been assigned to you the last couple of weeks. Prior to class on Wednesday, it will be turned in at the very beginning of class. Anything after that will not be accepted, and I totally mean that because we've had more than plenty of time, and I'm not giving you any homework tonight. Quiz on Friday. Quiz on the 10th, which I think is Tuesday. I'm telling you what sections are on. I changed my mind. Today's stuff will be on next Tuesday's quiz. 5.1 through 5.3 will be on Friday, and the test will be next Thursday. I think I got my dates right. Okay.